You know, our entire modern world, it runs on a mystery. A mystery that was solved with just a simple coil of wire and a magnet. Today, we're going to look at the exact moment that discovery was made and how the self-taught scientist behind it, well, he changed absolutely everything.
Okay, so picture this. We're in London. It's about 1831. A physicist, this guy Michael Faraday, he's up on a stage, and in front of him, there's just a simple coil of wire, and it's hooked up to something called a galvanometer. Now, that's just an instrument that measures electricity. But here's the kicker. There's no battery anywhere. And that needle on the galvanometer, it's sitting at zero, totally still.
So what does he do? He takes this ordinary bar magnet, and he just lowers it into the coil of wire, and bam! Suddenly, that galvanometer needle jumps to the right. Then he pulls the magnet back out, and the needle kicks again, but this time to the left. It's like an electric current just appeared out of thin air.
You can just imagine the audience, right? They are totally baffled. There's no battery, no power source you can see. It looks like a magic trick. I mean, how on earth could just moving a magnet create electricity? Well, to get to the bottom of that question, we really need to understand the man himself. Because when someone in the audience skeptically asked him, "What good is this little spark anyway?" his answer became absolutely legendary.
You see, Michael Faraday's journey to that stage, it was just as incredible as his discovery. This was not a guy who came from a world of science or, a privileged background. Not at all.
He was born into a really poor family, the son of a blacksmith, so his formal education was, well, pretty much non-existent. His real school was the bookbinder shop, where he was an apprentice. And talk about a stroke of luck. I mean, he was surrounded by books, and he couldn't help himself. He just devoured the pages, soaking up all the science he could find.
So how did he get his big break? Well, it was pure hustle. He started attending these public lectures by the great chemist of the day, a guy named Humphry Davy. And Faraday didn't just listen. He took hundreds of pages of meticulous notes, then went home, rewrote them, added his own beautiful diagrams, and get this, he bound it all into a book and sent it to Davy, basically asking for a job.
And it worked. Davy was so impressed, he hired him. Now, to put this in perspective, Humphry Davy was a scientific superstar. He discovered 8 new elements, invented the miner's safety lamp, a huge deal. And yet, Davy famously said that his single greatest discovery was Michael Faraday. Wow.
So now he's at the prestigious Royal Institution, and Faraday basically just lives in the lab. And there, he gets completely obsessed with one of the biggest scientific puzzles of the time. Okay, so here's what they already knew. Scientists had figured out that electricity could create magnetism. Back in 1820, a Danish scientist, Hans Christian Ørsted, discovered that if you run a current through a wire, it creates a magnetic field around it. Simple enough.
So Faraday just flips that idea on its head. He asks this beautifully simple logical question. Okay, if electricity can create a magnetic field, why can't a magnetic field create electricity? I mean, it makes perfect sense, right? If A makes B, can B make A? So he sets up this brilliant experiment to find out.
So, on August 29, 1831, he builds his test rig. He takes an iron ring and wraps it with 2 totally separate coils of wire. One coil is hooked up to a battery. The other one is hooked up to his galvanometer. And the result was not at all what he expected. When he had a steady current flowing from the battery, nothing. The galvanometer didn't budge. But for just a split second when he first connected the battery, the needle kicked. And then again for a split second when he disconnected it. That was it.
And that was the aha moment, the big realization. It wasn't the presence of a magnetic field that created a current. It was a changing magnetic field. The key was motion. The invisible lines of force from the magnet had to be cutting across the wire. So the field had to be either starting, stopping, or physically moving. That was the secret.
And with that, he hadn't just solved a puzzle. He discovered a brand new fundamental principle of nature, a whole new law of physics. He gave it a name, electromagnetic induction.
But Faraday, you see, he wasn't just a thinker. He was a doer, a brilliant builder. So after discovering this incredible new law of nature, his first thought wasn't just to write a paper about it. It was, okay, how can I use this?
And get this. Just 2 months later, he builds a device that could create a continuous current. It was so simple, really. Just a copper wheel that he spun between the poles of a powerful magnet. And as long as that wheel was turning, a steady electric current was being generated. He had just invented the world's very first electric generator.
But he wasn't done. He realized that his first experiment, the iron ring, it held another amazing secret. That setup wasn't just a tool to discover a principle, it was actually the world's first electrical transformer, a device that can actually change the characteristics of an electric current.
And here's how that works, basically. By changing the number of loops of wire in the second coil, you can totally change the electricity coming out. So, let's say you double the number of loops. Boom, you double the electrical pressure, what we call voltage. And why is that a huge deal? Well, that's the absolute key to sending power efficiently over super long distances. Like from a giant power plant all the way to your house.
Okay, so why does any of this matter? Why are we talking about it? Because Faraday's discovery didn't just stay in a lab notebook. It literally escaped the lab and remade our entire world from the ground up.
I mean, think about the shift. Before Faraday, if you wanted power, you needed a giant, clunky steam engine right there on site at your factory. Or you had these weak little chemical batteries. That was it. But after Faraday, you could generate massive amounts of electricity in one central place and send it anywhere. It meant the Industrial Revolution could literally flow through wires right into our homes.
This was the breakthrough. I mean, the big one. For the very first time in human history, we had a practical way to generate electricity on a massive scale. And think about this. Every single power plant today, I don't care if it's powered by steam, water, or wind, it all operates on the exact same principle that Faraday discovered with that simple little spinning copper wheel.
So remember that person who asked what good his little spark was? Well, in another version of the story, it was a politician who asked him that, and Faraday supposedly shot back with this incredible prophetic line because he knew exactly how valuable it would become.
And that kind of leaves us with a final thought, doesn't it? Just like Faraday's little spark, that seemed like nothing more than a curiosity. What newborn baby of science today, what seemingly abstract discovery is just waiting to completely redefine everything for us tomorrow?